Hello students, welcome to our channel. In this video we are going to see electrophilic addition. Introduction. There are two types of compounds. They are saturated compounds and the other one is unsaturated compounds. Saturated compounds contain only sigma bonds, whereas unsaturated compounds contain sigma and pi bonds. In saturated compounds, carbon-carbon single bonds will be there, whereas in unsaturated, carbon-carbon multiple bonds will be there. Double or triple bonds will be there. Here out of two bonds, one bond is sigma bond and one bond is pi bond. Pi bond and the other one is sigma bond. Here out of three bonds, two bonds are pi bonds and the another bond is sigma bond. So these are the two different types of compounds. There are two types of chemical reactions. They are addition reactions and the next one is substitution reactions. Let's see with examples. For example, if a compound A double bond B, it's an unsaturated compound because it has multiple bonds. When it reacts with a molecule XY, then we will get a product like this, AB. X and Y will be bonded with A and B. See here, no atom or no element is replaced, but instead XY is bonded with A and B. When XY is dissociated, then we will get X plus and Y minus. The pi electron will attack X plus, then Y minus will attack the other atom. Because Y minus has the bonding pair of electrons, with those electrons Y can make a bond with B. Next is substitution reactions. Here this compound is saturated because it has no multiple bonds. When it reacts with CD, the Y will be substituted by C. So we will get a product like this. Instead of Y, C will be bonded with B. These type of reactions are called substitution reactions. Here C is replaced by Y. So these also called as replacement reactions. This compound is called as benzene. And it has 3 pi bonds. 3 pi bonds. When it reacts with XY, we may think that we can get a product like this. One pi bond will be replaced by X and Y. But actually we won't get a product like this, because benzene will not undergo addition reaction like this. We can write benzene also like this. The ring inside the benzene structure is denoting the resonance of pi electrons. Due to this resonance of pi electrons, benzene is more stable, and compounds which are containing benzene ring, they are called as aromatic compounds. Aromatic compounds will not undergo addition reaction like this due to the resonance of pi electrons. Compounds, for example, alkenes C double bond C, alkynes C triple bond C, carbonyl compounds and cyanides, these compounds are called as aliphatic compounds, and aliphatic compounds will undergo addition reactions like this. Next, there are three types of addition reactions. They are electrophilic addition, next nucleophilic addition, and free radical addition. Free radicals are nothing but they have an unpaired of electron. Electrophiles are electron acceptors. Nucleophiles are electron donors because they have the bonding pair of electrons with them. And free radicals contain an unpaired of electrons with them. Next we are going to see about electrophilic addition reaction. For example, if a compound XY is dissociated, then we will get X plus and Y minus. Here the X plus is called as electrophile and Y minus is called as nucleophile. X plus is electrophile, Y minus is nucleophile because it has the bonding pair of electrons with it. For example, if a compound A double bond B, it is an unsaturated compound because out of two bonds, one bond is pi bond and the other one is sigma. When it reacts with XY, XY will be dissociated into X plus and Y minus. It will be dissociated into X plus and Y minus. The pi electrons will attack the electrophile, so we will get an ion like this. B will be possessing positive charge. So this is an intermediate, and this intermediate is called as carbocation. Carbocations are the intermediates in electrophilic addition reactions. Then again Y minus will attack the carbocation because it has the bonding pair of electrons with it. So we will get a product like this. This is a neutral product. Okay. So electrophilic addition has two steps. This is step 1 and this is step 2. First step will occur slowly and the second step will occur very fastly. In the first step, intermediate will form, that is carbocation. In the second step, product will form. So these are the two steps of electrophilic addition reaction. In this video, we are going to see three types of electrophilic addition. They are halogenation, hydrohalogenation, and the third one is hydration. So these are the three types of electrophilic addition we are going to see in this video. First, halogenation. Halogenation is nothing but addition of halogens like chlorine, bromine, iodine. For example, in chlorine molecule there are two chlorine atoms. Even though they both are same, they will be having partial positive and partial negative charge. So when they are dissociated, we will get Cl plus and Cl minus. So here the Cl plus is the electrophile and Cl minus is the nucleophile. Next, hydrohalogenation. In this type of addition, hydrogen and halogen will be added like HCl, HBr. So when HCl is dissociated, we will get H plus and Cl minus. So here H plus is the electrophile and Cl minus is the nucleophile. The last method is hydration. So in hydration, water will be added, which means H plus and OH minus will be added. Here H plus is the electrophile and OH minus is the nucleophile. As I told you already, in hydrohalogenation, hydrogen and halogen will be added to an unsaturated compound. Let's see with an example. Here we have an alkene. Alkene reacts with hydrohalogen. Okay, for example, we can take hydrochloric acid. The medium should be inert. The medium should be inert, or we can say non-polar solvents. So for these kind of reactions, non-polar solvents should be used. So hydrogen and chlorine will be added to each of the carbon in that alkene. So we will get a saturated product like this. If we use polar solvents for these kind of reactions, then during hydrogen and chlorine dissociation, these polar solvents will definitely interfere our reaction. Due to that only we are using non-polar solvents to avoid those interference. Okay, let's see the mechanism for this reaction. So CH2 double bond CH2, okay, when it reacts with the hydrochloric acid, so initially hydrochloric will be dissociated into hydrogen and chlorine, so the pi bond will attack the electrophile and we will get a carbocation intermediate in this reaction. Carbocation. So as I told you already, this step is first step and it is slow step. And also this step is called as a rate determining step. So usually in any chemical reactions, slowest step is called as rate determining step. Okay, next step 2. That carbocation will be attacked by nucleophile, that is Cl minus. So the carbocation is attacked by Cl minus. Okay. So we will get a neutral saturated product like this, and this step is second step and it is fast step. Okay, this is what the reaction mechanism of this reaction. The intermediate which is formed in this reaction is primary carbocation. So when carbocation is formed in a chemical reaction, it will stabilize itself by resonancing. Let's see with some examples. Okay, in this reaction, the reactant is propene. So propene is an alkene which has 3 carbons and it undergoes hydrohalogenation reaction with HBr in CCl4 medium. So we will get, in this reaction there are 2 products are possible. First one is 1 bromopropane and the next one is 2 bromopropane. So either bromine can be added in the first carbon or in the second carbon. But as per the Markovnikov rule, second product is more possible than the first one. Second product is more possible than the first one as per the Let's see the mechanism, then you can come to understand that why the second product is more possible than the first one. So in the first step, the pi electron will attack the electrophile. Here the electrophile is H+. Bonds in alkene will attack the electrophile. 2 intermediates are possible for this reaction because the hydrogen can be added in the second carbon or in the first carbon. So if it is added in the first carbon, then we will get intermediate like this. If it is added to the second carbon, then we will get intermediate like this. So the first intermediate is secondary carbocation. Secondary carbocation. And this one is primary carbocation. So as we know already, secondary carbocation is more possible than the first one because the stability of carbocation will lie in this order: tertiary, secondary, primary. So tertiary is the most stable carbocation, secondary is more stable, and first one is less stable because of inductive effect. Inductive effect is nothing but the CH3 groups will donate their electrons. Due to that, the carbocation will be stabilized for more time. So secondary carbocation is more stable. So the possible carbocation in this reaction is secondary carbocation, not primary carbocation. So this is first step. In the second step, this will be attacked by nucleophile, that is by Br minus. So Br minus will attack carbocation. So we will get 2 bromopropane. Due to the stability of secondary This is the second step of this reaction. Okay, let's see one more example for these kind of reactions. Here the reactant is 1-methyl propene. When 1-methyl propene undergoes hydrohalogenation reaction with HBr in CCl4 medium, then here also the possibility of two products for this reaction. If hydrogen is added to the second carbon and bromine is added to the first carbon, then we will get a product like this. If bromine is added to the second carbon and hydrogen is added to the first carbon, then we will get product like this. Now we should find which product is more possible than the other one. So here bromine is in the first position, here bromine is in the second position. As per the Morkonikov rule, second product is the most possible product than the first one, as per the Markovnikov rule. Okay, let's see the mechanism, then only you can come to understand that why the second product is most possible than the first one. So in the first, pi electrons in the alkene will attack the electrophile, that is H plus, in this reaction. So in this reaction, two carbocations can be formed. If the hydrogen is added to the first carbon, then we will get a carbocation intermediate like this, because the hydrogen is added in the first carbon. If the hydrogen is added to the second carbon, then we will get another carbocation, that is, if the hydrogen is. So we got two type of carbocations, but we need to find which one is most possible. So first one is tertiary carbocation and the second one is primary carbocation. So as we know already, due to plus A effect, primary carbocation is less stable and tertiary carbocation is more stable as per the Markovnikov rule. So the first step, okay. So in the second step, bromine, that is nucleophile, will attack the tertiary carbocation which has formed in the first step. So we will get saturated product, that is 2-bromo 2-methyl propane. So due to the stability of tertiary carbocation, we will get this product only as per the Markovnikov rule. Next, halogenation. In halogenation reactions, halogen atoms will be added to an unsaturated compound. Here ethene is reacting with bromine and we are getting 1,2-dibromo ethane. So the bromine molecule will be dissociated into Br plus and Br minus, and the electrophile of this reaction is Br plus. Let's see the mechanism of this reaction. So in the first step, ethene will attack the electrophile, that is Br plus. After attacking, we will get an intermediate. In this intermediate is formed, that is bromonium ion. Bromonium ion will stabilize its bromonium ion. It will resonance. Initially, the bonding pair of electrons, which is in between CH2 and Br plus, will be taken by Br plus. On account of that, carbocation will be formed initially. This carbocation an unstable intermediate will form. So this bond will go over there Due to that, unstable intermediate will form. Again, due to resonance, we will get the initial product, that is bromonium ion. So we will get the initial bromonium ion. By resonancing, these intermediates are stabilizing themselves. Next, step 2. In step 2, the carbocation will be attacked by the nucleophile, that is Br minus. After attacking, we will get a neutral saturated product, that is 1,2-dibromoethane. As I told you in the beginning, in hydrogenation, water molecule will be added with an unsaturated compound. Here ethene is reacting with water. After the addition, we are getting the saturated product, that is ethanol. Let's see this reaction. In the first step, pi electron will attack the electrophile. Here the electrophile is H+. So after attacking, we will get carbocation, which is the intermediate in this reaction. So the carbocation which has primary carbocation. The step 2, nucleophile will attack the carbocation. That means OH minus will attack the carbocation. Due to that, we will get a. Let's see one more example. Here the reactant is propene. Propene is going to be reacted with water molecule. So two products can be formed if hydrogen is like this. If hydrogen is added to the first carbon, we will get product like this. Now we need to find which product is most possible product of this reaction. As per the Morkonikov rule, second one is the most reaction because of the intermediate formation. See the mechanism. So initially propene will attack the electrophile, that is H+ by its pi electrons. So two carbocations can be formed in this reaction. So if hydrogen is added to the first carbon, secondary carbocation. Then if hydrogen is added to the first carbon, then we will get primary carbocation. So this one is carbocation and this one is primary carbocation. As we know already, secondary carbocation is more stable than the primary carbocation due to plus A effect. So secondary carbocation formation is the most possible intermediate formation in this reaction as per Morkonikov rule. Due to less stability of primary carbocation, it will not form in this reaction. Let's see the second step of this reaction. So in the second step, the secondary carbocation will be attacked by the nucleophile, that is OH minus. OH minus will attack the carbocation and we will get product like this. So this is what the hydration reaction mechanism. Now we are going to see the stereochemistry of electrophilic addition reactions. Let's see with an example. Here ethene is reacting with HBr in CCl4 medium. So initially the pi electrons will attack the electrophile. Due to that, intermediate will form. So the intermediate in electrophilic addition is carbocation. As we know already, the structure of carbocation is trigonal planar. The structure of carbocation which is formed in the above chemical reaction will be like this. The vacant p orbital will be above and below the plane. To indicate it is vacant, we are putting p inside the p orbital. So this is nothing but the vacant p orbital of carbon. Actually, the plane will be like this. The p orbital will be above and below the plane. It is above and below the plane. Now if Br minus, that is if nucleophile attacks this carbocation, there are two possibilities. Either it can attack above the plane or it can attack below the plane. If it attacks above the plane, then we will get a product like this. Br atom will be above the plane because it attacked above the plane. If Br minus attacks below the plane, then we will get product like this. The bromine atom will be below the plane. Just for your understanding, just see this model. If this is the structure of carbocation, that is the trigonal planar structure, if bromine attacks above the plane, then we will get the product. Then we will get product like this. So the carbon, hydrogen, CH3 will be on the plane. The bromine will be above or below the plane based on the side it attacks. So this is R and S. Both are mirror image to each other. Due to that, they are called as racemic mixture. So the product of this reaction will be racemic mixture. Now look at this reaction. In this reaction, two products can be formed by replacing the pi bond with hydrogen and bromine. We need to find which product is most possible product of this reaction as per Markovnikov rule. Let's see the mechanism of this reaction. As we know already, in the first step, pi electron will attack the electrophile, that is H+. After attacking the H+, we can get two carbocations. If hydrogen is attached there, then we will get a carbocation like this. If the hydrogen is attached here, then we will get a carbocation like this. Now we got secondary carbocation here. Here also we got a secondary carbocation. Now both are secondary carbocation. Now we need to find which is more stable carbocation by looking at the nearest carbons. The first one is more stable due to more inductive effect. It is more stable due to more inductive plus I effect. So first product is the most possible product of this reaction than the second one. Thank you for watching this video. We'll see you in the next video. Thank you. Bye.